All right, here's take 2 on this video. Let's see if we can get this done this time without any interruptions. Okay, so a software developer determines that her company can model their revenue R from a given product in hundreds of thousands of dollars, given the unit price of the product X in dollars, with the function R equals negative 0.1 x squared plus 4x. Create a linear quadratic system and solve it graphically to determine the price for which the company will earn $4.2 million. So we're wanting their revenue to be $4.2 million. So we need to come up with another equation where the revenue is just equal to $4.2 million. So instead of writing 4.2 million, I'm just going to put 42. And here we're given, because this is, let's see, it says given the product in hundreds of thousands of dollars, given the unit price of X dollars. So here is the other equation that we're using, where revenue is equal to negative 0.1 x squared plus 4x. So we're going to solve this graphically. Now, I have taught you, hopefully, at this point, how to find the vertex, negative b divided by 2 times a. You plug that back in and solve for the given value. But for the sake of time, we're not going to do that. We're just going to type it in to Desmos, because hopefully we already know how to do that. What was that? Plus 4x, negative 0.1 x squared plus 4x, and the revenue, y or r, equals 4.2 million or 42. Okay, so let's see here. Let's look at this graph. So if you look at the parabola, the revenue only reaches a high of 40,000 or 40, what did it say? It was in hundreds of thousands of dollars. So we wouldn't say 40, 100,000. That would be, 4 million. So it reaches 4 million. We're looking for where does the revenue reach 4.2 million, which is this line up here. And as you can see, the two lines never, the parabola and the line never ever intersect. Therefore, there is no solution. They are never going to earn $4.2 million. So there is no solutions, 0 solutions. Okay, so now you try this next one. I encourage you to pause the video and give it a try. I'll read it to you real quick. Engineers want to build a footbridge with steps across a steep valley. They can model the valley with the equation y equals 0.05x squared minus 4x plus 80, where y is the height above the lowest point and x is the distance from where they plan to start the bridge. If they start the bridge 80 feet above the ground and they want it to go down 1 inch for every foot to the right, then at what points will the footbridge start and end? So kind of think about this. We've got this parabola, and we're wanting to, that represents the valley, right? Or no, it wouldn't be this kind of parabola. It'd be this. It's a valley, not a mountain. So ignore that. So we got this valley here. They're wanting to put a footbridge. They start at 80 feet and it's going down 1 foot for every 12 inches, right? It goes down 1 inch for every foot. So it goes down 1 inch for every 12 inches. So I encourage you to pause the video and come up with a linear equation to show that they're starting at 80 feet and going down 1 inch for every 12 inches it moves to the right. That way we can find what points the graph would be, or the footbridge would start and end. Okay, so I went ahead and did this on Desmos. Here's my linear equation, 80 minus 1/12 x, because it's dropping 1 inch for every 12 inches we move to the right. So that's where I came up with this slope. And you can see where the points are. The bridge starts at 0.80 and it ends at approximately 78.73. All right, next example. Again, it says solve by graphing. So I'm going to flip back over here to Desmos. Everyone should know what the parent function looks like. Y equals x squared. So let's graph it first. And I encourage you to make a table. If you don't have access to Desmos, just plug in some values. I'd start with plugging in a 1 for y and solve for x and get some ordered pairs and then graph them. But we do have the convenience of Desmos, so let's use it. Here it says x is equal to 1/5, and then we had x or y let's see here, y minus 6 squared plus 6 fifths. So y minus 6 squared minus 6 fifths. Is that right? Y minus 6 plus 6 fifths. Okay, might help if I get the right signs. So we're looking for the points where the two graphs intersect. So I'm just kind of moving this around and zooming in a little. And I can see they intersect here at 2, 4, and they intersect here again at 3, 9. If I was to do a table of values, I would have came up with the same thing. We know the parent function has the point 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. We could keep on going. So when I made the table of values for this, then I would quickly see, okay, I come up with a 2, 4, and a 3, 9. So they intersect at these points, 2, 4, and 3, 9. Okay, example 6. Again, we're solving a system of equations. We have two parabolas this time. So it says to do it algebraically. So looking at this, I'm thinking, all right, this is set up for substitution. I have y equal to this value. So what I'm going to do is I'm going to plug it in, 2x squared minus, in place of y, I have 1/2 x squared plus 6. And that is equal to 4. Now notice I put it in parentheses so that I distribute this negative to both terms. So 2x squared minus 1/2 x squared minus 6 equals 4. I'm going to go ahead and combine my like terms, and I end up with 1.5 x squared equals 10. I'm going to divide both sides by 1.5. And x squared equals, what is 10 divided by 1.5? 10 divided by 1.5 is 6 2/3. 6 2/3. Or we could say 20/3, right? 3 times 6 is 18 plus 2. Okay, so take the square root of both sides, and I get x is equal to plus or minus 20/3. Okay, so what I'm going to do then is I'm going to pull up Desmos again and just type this in, 1/2 x squared plus 6. So 1/2, and in place of x squared, I'm going to put the square root of 20/3. Nice thing is when I square a square root, it cancels out. And then what did we have here? Plus 6. Okay, so I get 9 1/3 for one answer. And if this was a negative, again, we get 9 1/3. So my y value when x is square root of 20/3 is 9 1/3. So the x value is the square root of 20/3 plus or minus, and the y value for both is, what was it, 9.3 repeating, so that's 9 1/3, which would be 28/3, right, if we're being consistent here with our fractions. So those are my two ordered pair solutions. And now we're to example 7. We're going to use a system to solve. This is kind of like the problems that we did yesterday where we had them set equal to each other and we split it apart and said y equals this and y equals that, and then we graphed them. And that's exactly what we're going to do here. We're going to say, okay, well, y equals 2x squared minus 3x plus 8. And y equals 11 minus 4x squared. So I want to come over here to Desmos, and I want to type these graphs in, and we're just going to look for the points of intersection. So y equals 2x squared minus 3x plus 8. Y equals 2x squared minus 3x plus 8. And then the other one was y equals 11 minus 4x squared. Okay, so where do my two graphs intersect? Well, it looks like it intersects here at negative 1/2 10 and 1 7. So what are my solutions? Well, do we really care about the y's? Because looking at this, all we were solving for was if you look at the original equation, there were only x values in it. So my x values would be negative 1/2 and a positive 1 that make this true. So x could equal negative 1/2, or x could equal a positive 1. So these are my solutions for this problem. I hope that made sense. I tried to make this as quick as I could. 10 minutes, woohoo! So, all right, I'm done. Hope you guys understood this. If not, shoot me an email. Let me know what I can do to help you. Have a great day.